Hello and welcome to another Plotware video. In this video we're going to demonstrate using an Adafruit MCP2221A breakout board to drive an LE Tech Sup dm43b04 4-digit 7-segment display. It's a fairly inexpensive board. It's just a couple of euros, I think. I ordered it recently. It took about 2 weeks to get here from China, but after a few teething problems finding out how to use it because of a lack of documentation, I was able to come up with this video. In the video you'll see it being used, and there will also be some information that I have gleaned about the command structure, how to use the various commands. There aren't many. And all of that will be done using my PW scripter and a script, all of which is available online if you're interested. Before I run the demo, just a little word of warning. The camera that I used to film the breadboard didn't cope well with the contrast between the on and off segments. In order to improve visibility, I placed a coloured filter over the display. Right, let's run the demo. It'll only take a minute or so. I've already downloaded my Plotware scripter, and I've inserted the demo code. It's about 100 lines, including all the comments, and it's over half comments, into the edit field. I've got my hardware ready. Let's have a look. Right, let's give it power. Then we can put the filter over. And now we'll run the script by clicking on Execute Lines. I should have help for 5 seconds. 1.234 for 5 seconds. End dot. And that's the end of the little demo. Now, the dm43b04 was fairly difficult to find any information about it. I went to their website and I couldn't find any real description of the chip, but after a bit of searching around, I found out a few things about the chip was enough to make us do the demo, or to enable the demo. Specifically, the dm43b04 chip, its command sequences consist of 2 bytes. A command code followed by a data byte. The chip as such does not have an I2C address. Instead, it treats the first byte of an I2C write sequence, and the first byte is normally the address, and it treats it as a command code. Now, the MCP2221 DLL, it provides an interface, the I2C write interface, and that requires an I2C address, which for a 7-bit operation, it normally takes and shifts the address 1 bit to the left, and then sets the least significant bit to 0 to indicate a write operation. Fortunately, all dm43b04 command bytes have the least significant bit set to 0. What that means is that we can trick the MCP2221A I2C write interface by, where it wants the I2C address, we give it the command code shifted 1 bit to the right. The DLL itself will shift it back to the left later on. The other thing we have to do is place the data byte in a byte array and pass the byte array to the interface and set the number of bytes that are being written to 1. Even though we're sending 2 bytes. We're sending a command code which goes across as a pseudo address, and the data byte goes across as a single data byte. There aren't many command codes. There's lots of variants of a command, but there aren't many command codes as such. For example, the command code in hex 48 can be followed by a variety of values. 48 followed by 0 is display off. 48 followed by 1 makes the display visible. If you want to control the brightness, you have a choice of, do you control 7 segments or 8 segments? I couldn't make much sense of this. I found that 48 followed by a value in hex 11 or 21, 31 up to 71 controls the brightness of the 7 segments. And strangely enough, the brightest is 01. The 8 segment brightness seems to be the same as the 7, but it automatically turns all of the decimal points on. So I haven't found much use for the 8 segment brightness command. If you want to actually put a character onto one of the 4 digits, then you have to address which digit and then what bitmap, what set of 8 bits are required to be driven. What I mean by that is that the command in hex 68 will address the leftmost digit. The data byte that follows it is a bitmap, and the bitmap is given here. The least significant bit, bit A, tells the driver whether this bar of the segment display is to be set on or off. Bit B sets this one, and so on. And bit X, the most significant bit, is whether the decimal point should be displayed or not. It's all a bit weird, but once you get used to it, it makes some sense. The MCP2221A DLL provides over 60 APIs or functional interfaces. To actually run this particular demo, we only need 2. One is to gain access to the target chip. That's an open by index API. And the other one is the actual I2C write. This is the functional prototype for the I2C. It's written in C language, and what we need to do is simply create a wrapper in PWScripter language to gain access to the DLL's version of the I2C write routine. Once we've got the wrapper, we simply have the issue of how to send those 2 bytes. And that's where we have to trick the DLL API into using the command code as an address, an I2C address. And as you can see here, we take the command code and we right shift it by 1 bit. The data byte we simply drop into a byte array of length 1 and pass that as the final parameter, as given here in the DLL functional prototype, and we give it a length of 1. Once we've got that all sorted out, all we have to do is send some commands. And there are 3 commands to enable the display, set the brightness to a middle lowish value, and to send to the first digit of the display the ASCII character H. If you want to run this demo, you will need some software resources, specifically Microsoft Windows 7, 10 or 11 running on a desktop or a laptop. The DLL MCP2221-DLL_UM_X64 from Microchip Technology Incorporated. The freeware PWScripter interpreter from my website. A script ns-MCP2221A-dm43b04 from my website. Details about locating and installing the DLL, PWScripter and its script are given in other Plodware videos.